Now we want to design our processes. How can we do this? What tools are available to help us designing our processes? Well, first of all, we do a process flow analysis. This is a technique that is used to evaluate a process basically in terms of its different steps, its different activities that are required to transform some input to some output. And this gives us an overview of the current process, and this is a starting point to think and discuss about improving this process. You all have been through many processes in your daily life. Think about when you start a new semester at geotech, you have to register your courses. This is also a process that you go through. You have to get an overview of the available courses, of the courses that are offered. You have to check if you are eligible for all the courses, depending on your prerequisites. You have to register the courses yourself, but maybe not all courses can be registered by yourself. You need to go to your academic advisor and discuss the course registration. This might happen if you have failed a course in the past, if you are, for example, not starting in the winter semester but the summer semester. This makes things more complicated, and you might interact with RSA, of course, to do the course registration. And in the end of this process, hopefully, the outcome is that you have registered your courses and you have a schedule. So from having no courses registered as a starting point, having no schedule, the outcome of this process is that you know which courses you have and should study in this semester. So when we want to visualize a process, we call this visualization a process flow chart. And the most important thing is this increases the clarity. Maybe there are things that are confusing for you in the course registration process, and maybe the result of this confusion is that you're not really aware of the process, you don't know which steps to do, who is responsible for these steps, and when to do these steps. Now, if you have such a chart, you can make life for everyone involved easier. We have very sophisticated modeling languages for modeling processes. One very popular language is the Business Process Model and Notation, BPMN. This is a very well-defined modeling language for processes. This gives you a well-defined notation, and notation means which symbols and rules are there to combine these symbols. So we don't go into the BPN, I just give you an overview with some basic ideas, and keep in mind that in particular smaller companies, or when you start with this, they might not use a sophisticated notation in the beginning, and we are just on this level that we have a very basic and simple notation that I will introduce on the next slides. However, the benefit of this simple notation is that you will be exposed to the most important design elements in creating a process flow charts, and these design elements are almost always the same for all process modeling languages. So here you see on the right side different types of processes. A, multi-stage process, B, multi-stage process with buffers, and so on and so on. So you see 4 different processes here, and you see several symbols. First of all, you see the arrow that is connecting the symbols typically, the other symbols. You see the rectangles, the boxes, written with stage 1, stage 2, stage 3. All the rectangles are part, and we see two different types of triangles. One triangle where the top shows, the top shows to the bottom, a reversed triangle. And here we have let's say, a regular triangle with a long line on the bottom of the triangle. And it is very important that you understand these symbols, because every symbol has a meaning. Maybe in a different process notation, the symbols have different meanings, but the first idea that you need to understand is that every symbol is there for a reason. They are not placed there randomly, they have a certain meaning. The rectangles represent activities. We call them here, for this notation, stages of the process. These are certain actions, certain things that are going to happen. And the arrow between the stages, or the arrow, is used to connect different activities or different other concepts. So this means only after we completed stage 1, we can start with stage number 2, because the arrow is pointing from stage 1 to stage 2. And only after we completed stage 2, we can start with stage 3. Though it's not possible to start with stage 3 and go to stage 1 and then to 2. This is not allowed in this process. Although we cannot somehow complete only 50% of the task in stage 1 and then continue with stage 2. We should stick to the strict sequence. The triangle, where the top is showing to the top, is representing a decision. Maybe we can go either to stage 1 or we can go to stage 2. And the decision, there are several types of decisions, either or, and or, that we can follow. And this reversed triangle is representing an inventory. So for example, we produce something on a drilling machine in stage 1, and after we are completed drilling the holes, the product is stored in some inventory and is waiting until another machine, maybe for painting, is ready. Now here's a pause and a storage, a buffer. And what we have here in C and D, we also have parallel stages. That means here stage 1 and stage 2 can happen at the same time. The diagram does not say that these actions in stage 1 and 2 are actually happening at the same time, but it is allowed that they happen at the same time. And for C, we are producing different products. This would mean we are using different machines for stage 1 and 2. Let's assume you are doing grocery shopping with your family, and maybe 3 persons are going to the next Lulu. You have a shopping list, and then maybe 1 person is collecting. You could stick together as 3 persons, collecting all the stuff that you need together. Then you would have a multi-stage process. So first, for example, you go to the meat section, then you go to the dairy section, then you go to the vegetable section, and you stick together as the 3 persons. Then everything happens in a sequence. But you could also design this as a parallel process. For example, 1 person is going to the meat section and the other 2 persons are going to the vegetable section, and they are collecting the stuff at the same time. And through parallelization, usually we can become quicker. And in example number D, we are producing the same goods in both stages. For example, we have several machines of the same time where we can produce a product. And how do we see that the same product is produced? We just have a single finished good as an outcome. This is a way to represent in a graphical way processes. And now when we start to analyze the processes, what is usually important, and the first thing that's important are looking at the bottlenecks. And the bottlenecks are the longest tasks in such a process. For example, in process number B, let's say we need 60 seconds for the activities in stage 1 and 40 seconds for the activities in stage number 2. Yeah, then this means if something goes wrong for stage number 1 and we need longer, the total process will take longer in any case. However, in stage 2, if we have some delay, if the delay is less than 20 seconds, then the overall time of the process will not extend because stage 2 is not the bottleneck. Again, you can read more of the details in the textbook of Reid and Sanders in chapter number 3. Now let's look at Antonio's pizza and let's have a look at 3 different examples of processes. So Antonio is producing 3 different types of pizzas to address the needs of 3 different types of customers. The first type of pizza is just the standard topping and the standard crust. Antonio makes his pizza to stock, so Antonio is producing the pizza before there are any orders from his customers. Though this is shown in step number A. Though we have an inventory of ingredients and we use this inventory to make some dough. After we prepared the dough, we prepare the crust. Then we put the topping on the pizza, we assemble the pizza and we put the pizza in the oven. And the pizza is, once the pizza is finished, we put it in the finished goods inventory. And then once a customer gives us an order, we can quickly hand over the pizza and deliver it. So the customer order is only coming at the end of the process when the delivery is happening and triggers the delivery. We produce all the steps and we maintain a finished goods inventory. And this is very useful if we have a lot of customers. We know that we can sell our products anytime, and it's the same like preparing fries in McDonald's, for example. There will always be a customer in time before it gets cold and we can sell it. Okay, Antonio has a second type of pizza where he also uses a standard crust, but there's an individual topping. And this process is called assemble to order. Again, we start with an inventory of ingredients. We make the dough. After the dough is ready, Antonio prepares the crust. However, now we store the pizza that is not yet ready, and only once a customer order arrives, for example, for cheese pizza, quattro stagioni, then we put the topping on the pizza dough. And then we bake it and deliver it to the customer. This is called assemble to order, and you see that the process flow is changing, and you see the advantage of visualizing the process because it becomes much more clear what's happening. The final step is an individual made to order where the crust is also individualized to the needs of the customer, and this is a make to order process shown in the lower part of the picture. We start with the inventory of ingredients, and only when the customer order arrives, we start to prepare the dough, the crust, we assemble the pizza, bake it, and deliver it. So these are 3 examples of how to visualize a simple sequence of processes. Note, we do not have parallelization in this, but it's a good and easy way to start and show where the inventories are. And when the production process is triggered by the customer order. Here we have another flow chart from Antonio's Pizza that deals with the customers that are in Antonio's Pizza's restaurant. We have here a new symbol, an ellipsis. This is just a label that shows us that the process starts here, and we have another ellipsis with end that shows us that the process is ending here. See, here you also have an ellipsis, lost sale, and lost sales. These also are signals, notations that the process is ending at this step. So here the first activity happens. The customer enters our restaurant and is waiting to place the order. Okay, then we have a decision based on the waiting time of this customer. Now, the customer makes this decision. If the waiting time is too long from the customer point of view, and he decides, oh, that's bad service, I better go somewhere else, then we have a lost sale. If the customer is patient with us and accepts to wait longer, then finally the customer can place the order. Maybe the waiting time is not very long from the customer, and if the waiter is directly approaching the customer and gives him the menu, then the customer also can place the order. After placing the order, again the customer has to wait for the order. If the waiting time is not very long, the order arrives, and if the order is correct, then the customer is hopefully happy and is happy and enjoys a good time in our lunch. However, again, if the waiting time is too long, it might lead to a lost sale. And maybe if the order is incorrect, we bring something else than ordered, then we have to try to make up for this mistake, and a new order is placed, and we start the whole procedure again. If the customer is not willing to wait for the new order and leaves, then we again have a lost sales event. So you see, you can create with this simple notation more complicated processes with some inventory, decisions, events, and this helps to visualize and make the different processes, the different steps much clearer.